So we proved last time that we gave the condition for divisibility by 3, right? So a number is divisible by 3 if and only if the sum of the digits is divisible by 3. So the proof is clear, right?
Number 3. Yeah.
Right. So next one is similar, but the divisibility rule is for 9. So the statement is so a is divisible by 9 if and only if the sum of the digits is divisible by 9. Right. So how will you do it? Tell me.
Let's see. By 9.
Yes.
Mm,
Yes. So I think idea is similar. You can proceed like this.
yeah.
So yes, how to do? Tell me. So here, yes.
So I mean, we can again now do like factorization, like a1 multiply 10 to the n and so on.
Yes. So so suppose a is an n-digit number. So that is a equals to suppose a1, a2 up to a. So this you can write as a1 into 10 power n minus 1,
Mm-hmm.
10 power n minus 2, and so on. N minus 1 into 10 plus n. Yes. After this,
Mm-hmm. We need to apply like some kind of mod.
yes, modulo
But
9 we have to apply. So how to apply? Because we are checking divisibility by 9, so you have to apply modulo 9.
so then modulo 9 would be 1.
Right. So 10 is congruent to 1 mod 9. What about the other powers of 10? Higher powers of 10.
Yeah, I mean any power of 10 will be the same, right?
Right. So 10 power n. So that is 1 mod 9. So for
Right.
any n. Right. So this will be equal. It will be congruent to. So a1 plus a2 modulo 9. Right. So this part is the sum of the digits.
Mm-hmm.
Right. So now we can prove it. So suppose a is divisible by 9. So you are assuming. So you are proving this direction. So 9 divides a. So this implies a is congruent to 0 mod 9. Right.
Right.
Now a is equal to the sum of the digits. So sum equals to height 1 to n ai. So this is also congruent to 0 mod 9. So
Mm-hmm.
hence 9 divides the sum of the digits. Right?
Wait a minute. So you're saying 9 is 9. So how do you get from A to the sum of
Yes,
AI?
because what I showed previously that in modulo 9, a is congruent to the sum, right?
Mm-hmm.
Okay. So in
You're
modular
saying
notation, yes,
A is equal to equivalent to 0 mod 9.
yes, yes. So yes, so that is no. Before that, what I showed is a is equivalent to the sum of the digits, right? In modulo 9.
Right.
Right now,
Uh-huh.
when you start with this assumption that 9 divides a, I have a is congruent to 0 mod 9, right?
Uh-huh. And then
So then the
you
summation,
replace.
yes. So I can now
Okay,
replace
okay.
this by the summation, right?
Mm-hmm.
Right. So after this is fine, right?
Mm-hmm. Yeah.
Right. Similarly, other direction you can also do. So if you assume that the sum is divisible by 9, so 9 divides the sum. So this implies that the summation is congruent to 0 mod 9, but that is nothing but a. So implies that 9 divides a. So a number is divisible by 9 if and only if the sum of the digits is divisible by 9. Right.
Yeah, you just replace, right? A by
Yes,
the
yes.
sum of AI.
Right.
Okay.
Right. So fine, right? This one.
Yeah.
Okay. So the next one is, so a number a is divisible by 11 if and only if the alternating sum of digits, that is alternating sum of digits of a. So I'll explain what is that. Is divisible by 11. Right. So what do we mean by alternative sum of digits? So suppose so here they are taking that there are d integers. So we are taking a to b, a1, a2, a d minus 1, a d, suppose. Then the alternating sum of digits. So this is nothing but a1 minus a2 plus a3 and so on minus a4, like this. It will alternate.
But it is the sum. Why do you rest?
Yes, yes. So definitely alternating sum. Alternating sum means it will alternate between plus and minus. So it will be plus
Ah, okay,
minus plus
okay.
minus like this. Like
I
this it will
see, I
go.
see. Okay.
Right. So let us see an example. So if I so for example, suppose my number is 1331, right? Then this alternating sum of digits. So this will be 1 minus 3 plus 3 minus 1. That is 0,
Mm-hmm.
right? So this is the definition of alternating sum. So I think the definition is fine, right?
Mm-hmm. Yeah.
Yes. So now we have to prove that this thing is uh, yes, the divisibility by 11 you have to prove. So yes, how to do it?
I mean, we can, same thing, we can break it down like A1 multiply 10 to the n minus 1.
Yes. So from here I have a equals to. So here we are taking dg's. So d minus 1 plus.
Mhm.
Yes, then.
And then we can apply mod 11 to that.
Yes, yes. So what will happen if I apply modulo 11?
Then mod 11 is
Yes,
10.
yes.
So we will have 10A1, 10A2.
No. 10. So what you are having is, so you are saying that 10 is congruent to 10 mod 11. That is fine. But what about other higher powers? So 10 square equals to.
Um, okay, so that would be 1.
Yes, 10 square is 1. What about 10 cube? So you have to find some general condition, right? So what about 10 cube?
So 10 is also 1. 10 is equivalent to 1 or not?
No, no,
No, it's
no.
not.
That is not.
Not. It is not right. 10 to the 10 to the 3 is yes, and that would be 1.
Why?
Oh no, we need to find a number which is very close because no, it's not going to be that. Let's see. It would be 10.
Yes, that will be 10. So
10
yes,
more, 10 more 11. Right.
yes. So you can check that 10 power 4 will be again 1. Yes, so it is alternatively it is doing, but yes, one observation what you can do is that 10 is actually nothing but minus 1 modulo 11, right?
Minus 1.
Yes, so minus 1 modulo 11, right? So I can write it both,
Mm,
right? It is I can write it as 10
yeah,
also,
you can
minus 1 also,
write it like that. Yeah.
right? So what is the general thing is, so 10 power, so 10 power n, so let me write on here. So 10 power n is congruent to minus 1 to the power n modulo 11. So here you can see that it is alternatively plus and minus. So here you have minus 1 when n equals to 1. When n equals to 2, it becomes plus 1. So it is plus 1. Again, cube, it becomes minus 1 and so on. So it is alternatively.
Okay, 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 I see.
Right. So now it will depend upon so whether the d is even or odd, the number of digits. So now
Mm-hmm.
suppose without loss of generality, we assume the first case. So suppose d is some even number. Sorry, d is odd. So if d is odd, then what will happen to a if I apply modulo 11?
That
So this
would
is
be
this is my
D is
expression.
odd.
Yes. So it will be a1. Yes, tell.
A1 minus A1, right?
No. So d is odd we are taking, right? So d minus 1 is even, right? So this is minus 1 to the power d minus 1 plus a2 minus 1 to the power d minus 2 and so on.
Mm-hmm.
plus AD. So this in modulo 11. So now since D is odd, D minus 1 is even. So it will be A1 minus A2 minus AD minus 1 plus AD. Right?
Mm-hmm.
So this is nothing but my alternative sum of digit.
Right.
Right?
Mm-hmm.
So yes, so now how to prove it? So now we'll assume suppose A is divisible by 11, right? So this direction. So suppose 11 divides A. So this implies that A is congruent to 0 mod 11.
Right.
So now we can take this alternative sum. So we can replace. So this one is also 0 mod 11, right?
Mm-hmm.
So this implies that the alternative sum of digits is divisible by 11, right?
Yeah.
Yes. Similarly, I think similarly we can do the other way around. So if you assume that the alternative sum of digits is divisible by 11, so we can prove that A is also divisible by 11. So that is same way, right?
But what happens if D is even?
Yes. So D is even, then we can do that also. So that is not a problem. So let us do it. So if D is even, then it will have a extra minus sign outside. So then A is okay. Let us copy this one. Yes. So then if D is even, so D minus 1 is odd. So it will be minus A1 plus A2 minus A3.
Mm-hmm.
So this is what we have. But that is not a problem. So because so this is modulo 11. So you can take minus sign common from every.
Oh, I see. Yeah.
So this mod 11. So still now the thing inside the bracket. So this is the alternative sum of digits. So similarly we can proceed. So if A is divisible by 11, then this part has to be divisible by 11. So the inside the bracket part has to be divisible by 11. Right?
Right.
And similarly we can do the reverse part also.
Okay. Okay.
Fine.
Yeah.
Okay. So now let us see the next one. Okay. So fifth one, they are saying so find all incongruent solutions to the linear equations, linear congruences, right? So the first one is 8x is congruent to 6 modulo 14. Yes. So how to do it?
Well, incongruent. I mean, we do we find first like one solution and then we have the formula.
Yes, yes, that we can do. But first of all, we have to check whether the solution exists or not, right? So does it exist?
8, 14, whether they are coprimes.
Yes, tell.
So they have they
So what is the GCD of 8 and 14?
I mean it's not one. It's going to be two.
Right. So the GCD is 2, but the thing is, the so here we have AX is congruent to B mod M. So this is the general equation. So GCD of A and M. So that actually divides B, right? Because 2 divides 6. So solution exists, right?
The
So
GCD of
if B
A and
was,
M.
yes, yes. So that divides B, right? So hence
Mm-hmm.
solution exists, right? Because if we did not divide B, then we can directly say that no solution exists, right?
Okay.
Right. So the thing is, so first we have to solve. Yes. So now what to do after this? So we know that solution
So
exists, but now how to find the solution?
so you're saying because the solution of the GCD of A and M is a divisor of B, the solution
Yes.
exists.
Yes. Yes.
Yeah, I mean we find like the first solution based on the GCD.
Yes. Yes. How to do it?
So we have AY and let's say 8x. AY and 14z is equal to 2.
A Y. Okay.
And then we
Mm,
need to do the splitting.
yes. Equivalent algorithm we can directly use, right?
Yeah.
So 14 equals to how much? Yeah, 8 and 14 if I want to use the equivalent algorithm.
1 multiply A plus 6.
Right.
And then 8 is equal to 1 multiply 6 plus 2.
Yes. 2 is the GCD. So we have achieved it.
2.
So from
Yeah.
here, what I get is
You will have
8 minus 6, and 6 we can replace 14 minus 8, right?
14 minus 8.
So what I have is 2 times 8 minus 14, right?
Right.
So yes, so what I get is, so 2 times 8 plus minus 1 times 14. So this is 2.
Mm-hmm.
So this is our GCD of 8 and 14, right? So
Mm-hmm.
now we have to bring 6 here, right? So what do you have to do?
And you can multiply by 3.
Yes. So the thing is, you have to multiply the equation by 3. So if I multiply, so multiplying by 3 we have, so 6 into 8 plus minus 3 into 14. So that is 6, right?
Yeah.
So now if I take modulo 14, then what happens?
Modulo 14, right?
Yes.
You will have 6 multiplying 8 equal 6
Right. So that the
modulo
second term
14.
will go away, right?
Mm-hmm.
So so our original equation, what, 8x is congruent to 6 mod 14. So this was our original equation. So one solution is x equals to 6, right?
6.
So this is one solution, right?
Yeah.
Right. So how to find other solutions?
We need to apply the formula.
Yes. What is it? Do you recall the formula?
X is equal to x0 plus k.
Yes. What is k?
K is uh, all the solutions.
Yes, but we have to find it, right? So okay, let me go to the formula once.
That will be
So
G minus 1.
G minus 1 means, okay, let me show you the solution, it will be clear. So I think we did here, right? Somewhere, yes. So yes, no, this was the formula, right? X0 plus k into m by g. This is the formula, right?
Mm-hmm.
Right. So this is the formula. So k is from 0 to g minus 1. So this you have to tell m by g. So yes. So here what is m by g? So m here is, so the solution set is x0 plus k times m by g, where k is
Right.
from 0, 1 up to g minus 1. So here you have to identify what is all these things. So x0 is 6 that you already got. M is your modulo thing, so it is 14. And G is the GCD. So GCD we know that is 2,
2.
right? So that is 2. Right. So now for this problem, the solution set will be 6 plus k times 7, right? And
Mm-hmm.
k is 0 and 1 because G is 2.
Right.
So the first solution is 6 for k equals to 0. And if k equals to 1, so 6 plus 7, so that will be 13.
13.
Right. So there are only two solutions.
Right.
Okay.
Yeah.
Okay. So now part B is, so part B it is saying 66x is congruent to 100, sorry, 100 modulo 121. Yes.
So we find the GCD of 66 and 21 and 121.
Yes. So what will be that?
11.
Yes. Now,
But 11 is not a divisor of 6 of
yes.
100.
So 11 does not divide 100. So a solution does not exist, right?
Yeah.
So there are no solutions, right?
Yes, there's no solutions.
Okay. So the third part is 21x is congruent to 14 modulo 91. Right. So yes. So now yes, first we have to find the GCD.
Mm, 1.
GCD of 21 and 91. Yes. How much is that?
1.
No, not one. Check by.
There's no 1. It's, 7.
Right. So 7 is divisible by both. So 7 divides both of them, and also 7 divides 14. So there is a solution, right?
Yeah.
So this implies a solution exists. So you have to find the solutions. Yes. So how to start?
Let's do the Euclidean.
Yes. So 91 will be,
So 91 will be equal to 4 times 21,
right, plus.
7.
Okay. So
And
yes. So
then,
it directly gives us the thing, right? GCD.
yeah, yeah.
So yes. So 7 is nothing but 91 minus
91.
4 times 21, right?
Uh-huh. Yes.
Okay. So yes. So now, but I want 14. So what should I do?
We multiply by 14.
No, by 2, right?
We multiply.
So you multiply by 2, that is sufficient, right? Because I have 7
Why?
on the
Oh, I see. Yeah, you have to multiply by 2. Yeah.
right. So multiplying by 2.
14
So
equal to.
91 times 2. Okay.
Yeah.
Minus 21 times 8. So
Mm-hmm.
this is congruent to 14.
14.
Let me write down. So this is equals to 14. Now taking modulo 91. So minus 21 into 8 is congruent to 14 modulo 91. Right?
Right. Yes.
Okay. But
So,
the thing is, we want to take positive things. So
yeah, we can decrease 91 in 21. It will be 70.
why 70?
Because we want the positive, right?
Yes, yes, positive. So it will be 21. You are saying 70, right? So it will. So this is same as 70 times 8 is congruent to 14 modulo 91, right?
Mm-hmm.
So this is a solution, right?
Yeah.
So x equals to
Right.
70 is one solution, right? Now how to find all other solutions?
And 0 plus k the multiply m over g.
Right. So it is m over g, and k is from 0, 1 up to g minus 1. Okay. So
Mm.
here, what is x0? So x0 is
Uh,
70.
70.
M is
N is 91.
right. So M is 91 and G is
7.
7. Yes. So M divided by G will be how much?
14. No,
Mm,
13. 13.
right.
13k.
Right. So 1 minute. So GCD of yes 13, right?
Yep. 13k.
So K equals to 0, 1 up to 12.
Mm-hmm.
Right. So let us see the full set. So first one K
70.
equals to 0 is 70. That is fine. Then plus 13 will be
83.
right. Then
96.
okay. Next
109.
409. No, no. 96 plus 13, right? 109, right?
96. Yeah.
Okay.
122.
122, yes.
135.
Yes.
And then we need to, I don't remember, but in certain point we need to go back
Yes, yes. So we
below.
have to, yes, we have to decrease them to the modulo thing, right? So from 96
To
onwards only. So 96 modulo 91, right? We have to do.
modulo 91.
Yes.
So we never go beyond 91.
Yes, yes.
Always.
We have to do the modulo thing, right? So 96 is
Mhm.
5, right? Then what about 109?
39.
18, right?
It's modulo 90, 91. That would be,
Right.
yeah.
So next one will be, if you do modulo,
31.
right? This one will be 44, right?
44.
Yes. Then I think we can just add 13 here. So 44 plus 13 will be 57, right?
57.
Right. Then,
You say 70.
okay. So then we are already repeating it. So here we can end.
Okay. It's not like we would have 13 solutions.
No, no. 13 solutions. Yes, it may not be all distinct. Yeah, because you have to finally take modulo, right? So the complete set is 5, 13, 31, 44, 57, 70, 83. So this is the
Okay,
full set
okay.
of solutions.
Okay, 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 okay.
So I think this is fine, right?
Yeah.
Right. So the next one is,
So we don't have a way to know the number of solutions
yes,
because
number of
K is
solutions.
not
We know
is
that
not the answer.
yes, so we know that maximum solutions, how many we can have, that I know that it will have G solutions, where G is the GCD, but actually it will have less than equals to G solutions. So because some of the solutions can be repetitive, so yes,
Mhm. Okay, okay, okay.
right, fine,
Yeah.
okay. So next one is 6. So saying determine the number of incongruent solutions from the, so determine.
It's the same, right?
Uh, yes, not exactly, because they are. Uh, the thing is, part 5 they are saying to find all the incongruent solutions, but here they are asking to only to find a number of solutions, incongruent solution.
I mean, we still need to express it
Yes, so you
as
don't have to
before.
actually find the solution, but you have to only find the number of solutions.
Okay.
Yes, so the first part is 72x is congruent to 47 modulo 200.
Mhm.
Yes.
I mean, we do the GCD 72 for 47 is not the prime.
47, yes, yes, 47 is the prime, right?
So the GCD of GCD of 72 and 200 must be 1. If not, there's no solution.
Yes, yes, but what is the GCD?
Let's see. 8.
Right, the GCD is 8, and so 8 does not divide 47.
Right.
So this implies no solutions, right?
Yeah.
Okay, what about part B? So it is 4183x is congruent to 5781 modulo 15087. Yes, you can check using some calculator. So what will be the GCD? or what is the prime factorization. From there we can get the GCD.
Yeah. Let's see.
Yes. So I think
Oh, 141.
141. Okay. What is the prime factorization?
I mean, I just find that I just found GCD. Without the
141
prime.
you're saying. Okay. Because 141 does not divide. So let me write down. So 4183, what I got, the prime factorization is 47 into 89, right?
Yeah, it's not correct.
Yes, so 141 will not come. So next 5087, I think that is, let me check. Yes, so it is 3 times 47 times 107. So GCD is 47.
Okay.
Right, and the third one also. So 5781. So this will be 3 times 41 times 47.
hmm
So this implies that 47 divides 5781. So that is fine. So solution exists, but how many solutions? That is the question.
Yeah, I mean, we need to solve all the solutions. We need to find all the
No, no,
solutions
we don't have to
before, right?
find all. We just have to find the number of solutions, incongruent solution,
hmm
because this will be a big number because the numbers are bigger. So that's why we
Right.
don't have to find all the things.
But we only have the formula.
Right. So the formula is yes. So x0 plus k times m by g, g minus 1. Right.
hmm
So here x0 we don't know till now, but that is fine. And m here is this one 15087. So m by g. So m by g is 3 times 107, right?
Yeah.
So that is, let me check, 321, right?
hmm
So k is 0 1 up to g is 47, so it is 46, right?
Uh-huh.
So there will be 47 solutions, right?
No. I mean, not necessarily, right?
Yes. So yes, so that how to understand it. So because so here actually, so previous problem, if we go back, so here what was G? So G was 7, right? Sorry,
Right.
1 minute. Mm, yes,
He was
GCD is
7.
7, right?
Yeah.
Okay, okay, sorry. Here I think there was a mistake. So G minus, so it is 6, right? Not 12. G minus 1, I think. Why I wrote 12, I don't know. So G minus 1 is up to 6, right? So there are 7
Right.
solutions. So yes, though that is correct, right? That is not problem. So there are 7 solutions.
Mm-hmm. I see.
Yeah.
I see.
So here also same thing. So there is so the problem. So it is not a problem because since the GCD is a prime number, so all the solutions will be incongruent. So hence it will be 47 solutions.
Okay. Okay.
So hence, right,
Mm-hmm. Yeah. Okay. Okay.
right. What about, so this was part B. 1 minute. Yes, part C. What about part C? So part C is 1537. X is congruent to 2863 modulo 6731.
Mm-hmm.
Yes. So first of all, what will be the GCD?
Let's see.
So yes, I think we can do the prime factorization. So 1537. So this is 29 into 53. And what about 6731? What is the prime factorization?
$53.
Yes, 53 is one factor. So 53 times 127. So the GCD is 53. Right. But does 53 divide 2863? That is the question.
No.
Yes. So 2863 is nothing. I think it is 7 times 409. Right. 409 is also a prime. So I think so. And 53 does not divide. 2863. So this implies no solution, right?
No solution.
Okay. Right. So next 7 and 8 maybe you can do later. So these are some program thing.
Right.
Yes. So next one is the ninth problem. So ninth one is, okay, let us understand the question. So here is a so polynomial thing, right? So polynomial means we have to, that last theorem we did, right? So that more polynomial theorem we did, right, last. So I think that we have to that will be application here. The polynomial roots mod p theorem. Okay. So the question is how many solutions are there? So to the congruence. So the polynomial is x power 4 plus 5x cube 4x square minus 6x minus 4 is equals to is congruent to 0 mod 11, where x lies between 0 and 11. So that is fine.
Mm-hmm.
Yes. So the thing is, at least by the polynomial root mod theorem, I know that the maximum number of solution it can have is 4, because the degree is 4, right? Because the highest degree is 4, we have to maximum it can have 4 solutions, right? So yes, but now we have to find out exactly how many solutions you have. Yes. So how to find? So usual. So we can do the usual thing. So means normally we can find out the roots of this polynomial. We can try to find out that.
And the roots.
Yes, yes. Normal roots we know, right? So there are various techniques to find roots of the of a polynomial, right? So we can use any of them.
Okay. Do you mean factorization?
Yes, yes. Some factorization we can do. Yes. So there is something called the vanishing method, right? So I don't know the name, means name, whether you have heard like this or not. So the vanishing method states that, so you can just guess the things, right? So for example, if I take x equals to 1, right? So then we can just check whether it is working or not. So for example, it will be 1 plus 5 plus 4 minus 6 minus 4. So that is 0, right? Right?
Why do you do that?
Yes, tell.
I mean, why do you do that to find whether the sum?
No, no. The thing is, I just put x equals to 1. So my
If x
aim
is
is
equal
to
to
check
1,
whether 1 is a solution or not, right?
yeah, okay, because x is between 0 and 10, you are guessing.
Yes, yes. X is between 0 and 11, is less than equals to 10. Yes. So I want to check whether 1 is a solution or not. So here I can
Mm-hmm.
see that this one is getting factored. Basically, this one satisfies. X equals to 1 satisfies, right? So 1
Mm-hmm.
will be a root. But then, so I have to express like this. So this equation, I can write it like some x minus 1 times some g of x, right? I have to find what is g of x. Because g of x will be a degree 3, right? So this will be a degree 3 polynomial. So how to
Degree
find?
3, yes.
Yes. So do you know how to find this g of x?
No, I don't remember.
Okay.
I
So
mean,
yes,
yeah, I just need to divide, but I don't remember the method.
yes, yes. So this g of x is actually we can use the long division just to divide this x minus 1, or we can use vanishing method or similar techniques to do it.
Okay.
Okay. So for example, so let me write down. So right. So here I know that I want to factor out x minus 1. So the first term is x power 4. So I have to multiply by x cube. Then I have x power minus x cube, right?
Mm-hmm.
If I want to adjust, then but I have plus x power plus 5x cube. So to adjust it, I have to make it 6. So next term is 6x square, then minus 6x square. So to adjust it becomes 10x square. So it will be 10x into x minus 1. So now minus 10x and plus 4x to make it minus 6x. So plus 4 into x minus 1, and this is minus 4. So now you can check that it is getting adjusted.
Mhm.
So now I get my gx, that is x cube plus 6x square plus 10x plus 4. So this is my gx, and from here I have to find the other roots. Fine.
I see. We can keep guessing or not.
Yes, exactly. Yes, you can. So actually, this guess came because you can see that just the if I take the sum of the coefficients, it is 0. So of course, x equals to 1 is a root. So now I have to find other roots from this cubic equation and then find the roots. Okay. So maybe we
Mhm.
will continue tomorrow. So because it will take some time.
Okay, thank you so much. Bye.